Werner Heisenberg was born on 5 December 1901 in Vienna, Germany. He grew up in an educated family because his father was a university professor. Since he was young, Heisenberg was interested in science, philosophy, and music. He especially enjoyed reading the work of Plato. He studied physics and mathematics at Louis Maximilian University in Manchester, later at the University of Göttingen. During his study, he learned from famous scientists such as Ernst Rutherford and Max Born. In 1923, Heisenberg completed his PhD with research of turbulence in fluid flow. His professor recognized his talent and believed that he would become an important physicist. This experience helped him become one of the most influential scientists in quantum physics. In 1925, Heisenberg introduced a new mathematical approach to quantum mechanics. Together with Max Born and Percival Jordan, he developed metric mechanics, which is become one of the foundations of quantum theory. In 1927, Heisenberg introduced the uncertainty principle. The principle states that it is impossible to know both the exact position and momentum of a particle at the same time. This discovery changed scientists' understanding of how particles behave at the atomic level. Because of his important contribution to physics, Heisenberg was awarded the Nobel Prize in Physics in 1932. His discovery played a major role in the development of modern quantum mechanics and continue to influence scientific research today. Now, I will talk about Heisenberg's career and personal life. At the age of 35, Heisenberg became a professor of theory physics at the University of Leipzig. He was one of the youngest professors in Germany at that time. Many students come to study under him, and some later become famous physicists. Besides quantum mechanics, Heisenberg also conducted research in other areas of physics, including atomic nuclear, comet rays, ferromagnetic, and quantum field theory. His work helped scientists better understand matter and energy. Outside of science, Heisenberg loved classical music and was a talented pianist. He often played the piano in his free time. In 1937, he married with Elizabeth Schoumacher, and they have 7 children together. He also enjoys spending time with his family and relaxing in nature near the Bavarian Alps.
Next, we are going to explain about Werner Heisenberg's discoveries. Number 1. Metric mechanics, 1925. One of Heisenberg's earliest and most important contribution was metric mechanics, developed in 1925. Metric mechanics was the first complete mathematical formulation of quantum mechanics. Instead of describing particles using classical paths and trajectories, it used mathematical matrices to predict their behavior. This breakthrough became one of the foundations of modern quantum theory and helped scientists better understand the microscopic world. At the time, classical physics could not fully explain the behavior of atoms and subatomic particles. Metric mechanics provided a new way to describe these particles and their interactions. Although the mathematics was complex, this discovery played a crucial role in the development of quantum mechanics and influenced many physicists. Number 2. Uncertainty principle in 1927. In 1937, Heisenberg introduced his most famous discovery known as the uncertainty principle. This principle states that it is impossible to know both the exact position and momentum of a particle at the same time. The more accurately one property is measured, the less accurately the other can be known. This discovery changed the way scientists view nature because it showed that uncertainty is not caused by imperfect instruments but is actually a fundamental property of the quantum world. The uncertainty principle challenged the traditional belief that everything in nature could be measured and predicted precisely. It revealed that there are natural limits to what humans can know about the behavior of particles. Today, this particle remains one of the most important concepts in quantum physics. Next, founder of quantum mechanics. Besides his individual discoveries, Heisenberg played a major role in establishing quantum mechanics as a scientific theory. He worked with famous physicists such as Niels Bohr, Max Born, and Arnold Sommerfeld. Together, they developed ideas that explain the behavior of atoms and subatomic particles. Because of these contributions, Heisenberg is widely recognized as one of the founding fathers of quantum mechanics. His collaboration with other leading scientists helped create a new understanding of the physical world. Their work laid the foundation for many later discoveries in physics and helped establish quantum mechanics as one of the most successful scientific theories in history. Last but not least, theory of ferromagnetism. Another important contribution by Heisenberg was the theory of ferromagnetism in 1928. This theory explained why materials such as iron, cobalt, and nickel can become magnets. Heisenberg showed that magnetism is caused by quantum interactions between electron spins inside atoms. His work helped scientists understand magnetic materials and become an important application of quantum mechanics in solid-state physics. This discovery was significant because scientists previously did not fully understand why certain materials were magnetic. By applying quantum mechanics to magnetism, Heisenberg provided a scientific explanation for ferromagnetic behavior. His theory continues to be important in the study of magnetic materials and modern technology. That's all, thank you.
Before quantum physics, most scientists believed the universe behaved like a giant machine. If you knew the exact position and speed of an object, you could predict its future perfectly. This idea mainly came from classical physics developed by people like Isaac Newton. However, when scientists began studying extremely tiny particles such as electrons, they discovered something strange. Electrons did not behave like normal objects. Sometimes they behave like particles and other times like waves. Heisenberg became one of the scientists trying to solve this mystery. In 1927, he introduced one of the most famous ideas in physics, which is the uncertainty principle. The principle says, the more accurately we know the position of a particle, the less accurately we can know its momentum. And the more accurately we know its momentum, the less accurately we can know its positions. This was revolutionary because Heisenberg was not saying that our instruments were weak or imperfect. He was saying that uncertainty is built into nature itself. The main formula of uncertainty principle for position-momentum relation is delta x times delta p is greater than or equal to h bar over 2. The delta x represents the uncertainty in the position of a particles. It refers to how precisely scientists can determine the actual location of an electron or quantum particles. The delta p represents the uncertainty in the momentum of the particles. Momentum is the product of an object's mass and velocity. The symbol h bar or the reduced Planck constant is the value of Planck constant divided by 2 pi. It is a fundamental constant in quantum physics. Although its value is extremely small, it plays a major role in the behavior of particles at the atomic and subatomic scale. Now, let's look at the energy-time relation. The formula is delta E times delta T is greater than or equal to h bar over 2. Here, delta E represents the uncertainty in energy, and delta T represents the uncertainty in time. The meaning is very simple but profound. There is a fundamental limit to how precisely we can measure energy over very short intervals of times. Werner Heisenberg proposed the gamma-ray microscope experiment to explain why we cannot measure both the exact position and momentum of an electron at the same time. First, a radioactive source emits gamma rays with very short wavelength. It is perfect for observing tiny particles like electrons. These rays pass through narrow slit, forming a thin focused beam aimed at the electrons. When the photon strikes the electron, it scatters in different directions. Some scattered photons enter the microscope lens, revealing the electron's position. On the detector screen, they form bright spots, sometimes even two spots, showing where the location is located. But here's the catch. Those high-energy photons also transfer momentum to the electron, changing its velocity and direction. This makes the electron's momentum uncertain. So, short wavelengths give us precise position but cause large momentum uncertainty. Longer wavelengths reduce disturbance but make position less precise.
Now, let's look at the timeline of Heisenberg's major contributions and achievements. In 1935, he developed matrix mechanics. In 1927, he introduced the uncertainty principle. In 1932, he was awarded the Nobel Prize in Physics. During the 1930s and 1940s, his work inspired further research in atomic physics and quantum chemistry. These contributions later became the foundation for many modern technologies. Now, I will explain the impact of these contributions in more detail. First, the development of matrix mechanics provides scientists with a new mathematical framework to describe the behavior of atoms and electrons. This became one of the foundations of quantum mechanics. Next, the uncertainty principle changed how scientists view the microscopic world. It showed that the exact position and momentum of a particle cannot be measured simultaneously and challenging the ideas of classical physics. Heisenberg's achievements were recognized internationally when he received the Nobel Prize in Physics in 1932 for his contribution to quantum mechanics. His theories also inspired further research in atomic physics and quantum chemistry, helping scientists better understanding atomic structure and chemical bonding. Finally, his discoveries laid the foundation for many modern technologies, including nuclear science, medical imaging, and quantum technologies. Overall, Heisenberg's works revolutionized modern physics and continue to influence science and technology today.
Heisenberg's uncertainty principle has become a part of modern quantum and has many practical applications today. First, we have quantum computing. Quantum computers use quantum mechanical principles to process information through quantum bits. Heisenberg's work on quantum mechanics provides the foundation for understanding how particles behave at the atomic level, enabling faster solutions to complex problems than classical computers. Next, we have medical imaging. Magnetic resonance imaging (MRI) use quantum behavior of atomic nuclei in magnetic field to produce detailed image of the human body. The technology rely on quantum mechanical concept that originate from the Heisenberg theoretical work. Third, we have semiconductor technology. Modern electronic devices such as smartphones, laptops, and microchips depend on the quantum behavior of electrons in semiconductor materials. Heisenberg quantum mechanics help explain and predict electron movement within this device. Next, we have laser technology that operate through the interaction of atom and light in the quantum level. Moreover, we have electron microscopy. Electron microscope use beam of electron instead of visible light to observe a extremely small structure. Quantum mechanics explain the wavelength behavior of electrons, allowing scientists to obtain highly detailed images of intelligence and biological samples. Lastly, we have quantum cryptography. Quantum cryptography uses the principle of quantum mechanics to secure communications. Any attempts to intercept or measure quantum information change its state, making unauthorized access detectable and improving data security.
Werner Heisenberg's contribution to quantum chemistry. Heisenberg's development of matrix mechanics and his uncertainty principle have established the foundation of quantum mechanics. providing scientists with new ways to understand the behavior of electrons and atoms. Influenced during his era, his discoveries transformed the scientific understanding of atomic and subatomic particles, inspired further research in atomic physics and quantum chemistry, and earned him the 1932 Nobel Prize in Physics. Legacy in modern science and technology. Heisenberg's work continues to influence modern technology, including quantum computing, semiconductor device, medical imaging, laser technology, electron microscopy, and quantum cryptography. These advances rely on principles of quantum mechanics that he helped establish. Werner Heisenberg's groundbreaking idea changed how scientists view the microscopic world and remain essential to modern physics, chemistry, and technological innovation.